We're at a point now where seeing really isn't always believing, especially when you're on a video call. What we're diving into today is this incredible and honestly pretty terrifying arms race between real-time deepfakes and the tech that's trying to catch them. It is a massive game of digital cat and mouse, and believe me, the stakes are getting higher every single day. So, what's with this number? $620,000. Well, that is the actual amount of money a single person in China lost because a scammer used a real-time deepfake to impersonate their friend on a video call. This isn't some far-off future problem. No, this is happening right now, and it just goes to show you how scarily convincing this technology has become. All right, so to really get a handle on this, we've got to understand the threat itself. We're not just talking about any old deepfake. This is a specific kind that's jumped from being an offline, Hollywood-style editing trick to something way more immediate and way more dangerous. And this is it, a real-time deepfake, or an RTDF. The two words you really need to remember here are live and interactive. This means an imposter can react to you, answer your questions on the fly, nod along, all while wearing someone else's face like a perfect digital mask. And that is what makes it so risky for things like job interviews, financial approvals, or even just a quick catch-up call with a friend. It sounds like something straight out of science fiction, right? I mean, how can a normal computer possibly pull this off live in the middle of a call? Well, it's all thanks to this really sophisticated multi-step process that happens in literally the blink of an eye. So here's the breakdown of how it works. First, the software finds the imposter's face and maps out all the key landmarks, their eyes, nose, mouth. Then, a pre-trained AI model generates the target's face and perfectly maps it right onto the imposter's expressions. Step 3 is the real magic. It seamlessly blends that fake face onto the real head, fixing things like skin tone and lighting. And finally, this totally fake video is fed through a virtual webcam. So to you on Zoom or Teams, it just looks like you're talking to the real person. It's wild. Okay, so the fakes are getting really, really good. But on the other side of this arms race, you have the digital detectives, the detection methods that are designed to spot these imposters. And they've basically got two main strategies up their sleeves. Think of it like this. Passive detection is kind of like a forensic investigator dusting for fingerprints at a crime scene. It's just looking for the little clues the AI accidentally left behind. But active detection, that's more like a sobriety test. It's not looking for clues that are already there. It forces the subject to do something that will prove whether or not they're faking it. So let's look at that passive approach first. Here's the thing. Even the most advanced AI models are not perfect. When they're generating a face, frame by frame by frame, they can leave behind these really subtle traces of their work, these little digital fingerprints. And what's so fascinating about this is that most of these glitches are almost impossible for a human to see. We're talking about things like spatiotemporal inconsistencies, which is just a really fancy way of saying the video doesn't quite flow right from one frame to the next. You might also get unnatural flickering, weird lighting that doesn't match the room, or even strange blinking patterns. These are the tiny giveaways that AI algorithms are trained to hunt for. But what if the deepfake is just too good? What if it doesn't leave any obvious fingerprints? Well, that's where active detection comes in. Instead of just watching and waiting, you make a demand. You give the person on the other end that digital sobriety test. This is what's called a challenge response system, and the core idea is just brilliant in its simplicity. You ask the user to do something that is incredibly easy for any real person to do, but that creates a total computational nightmare for the deepfake software that's trying to render it live. So, how do you actually break a deepfake? Well, this table lays out its biggest weak points. Ask someone to turn their head way to the side. The AI struggles because, get this, most models are only trained on pictures of people facing forward. Ask them to cover their mouth with their hand. The AI gets totally confused about where the face ends and the hand begins. If they poke their own cheek, the landmark detectors just can't handle it. Or a sudden flash of light from a phone, the color correction just goes haywire. And this image just illustrates the point perfectly. On the left, you've got a real person covering their face. Easy, right? Simple. On the right, the deepfake tries to do the same thing, and look at that. The whole system just can't handle it. You get these distorted, glitchy artifacts all over the place. The mask has been shattered by one simple human gesture. So, these active challenges seem like a fantastic solution. Problem solved, case closed, right? Well, not so fast, because this arms race has a massive twist. The same kind of AI that creates the fakes is now being used to hide them. And here is the absolute game changer. A new type of AI, called a denoising diffusion model, can take a glitchy deepfake and essentially launder it. It polishes the image, smoothing over the exact artifacts and digital fingerprints that passive detectors are trained to find. It's basically erasing the evidence. So how on earth does that work? It's actually a pretty wild process. Think of it like restoring an old, damaged photograph. First, the AI takes the deepfake and, this is the crazy part, it intentionally adds digital damage, or noise, making it look all grainy. Then, it uses its training to perfectly remove that noise. But here's the trick. In doing so, it doesn't just go back to the original. It reconstructs the image from the ground up, intelligently filling in the gaps and fixing things like blurry edges, weird shadows, and unnatural skin textures along the way. So, just how effective is this cleaning process? This is where it gets genuinely alarming. This graph here shows 9 different state-of-the-art deepfake detectors and how well they perform against deepfakes that have gone through this cleanup process. Okay, let's break this down. The vertical axis on the left shows the detection rate, how many fakes they catch. Higher is obviously better. Along the bottom, the horizontal axis shows the number of denoising steps, basically how much cleaning gets applied. Now look at the far left, at 0 steps. The detection rates are pretty good, right? Most are way up there, but just watch what happens. The second you apply even a single denoising step, those lines just plummet. By the time you get to 10 or 25 steps, I mean, look at them. Many of these advanced detectors are barely better than a coin flip. And what does this actually look like? Well, before the cleanup, a deepfake might have some obvious giveaways, like weird shadows or even 2 sets of eyebrows, which is a surprisingly common glitch. But after this DDM process, those artifacts are just gone. The AI has even added back fine details like realistic skin texture, making it so much more believable, not just to our eyes, but to the detection algorithms too. And this brings us to the really big question. If deepfakes can be made perfectly, and the evidence of the fake can also be erased perfectly, what do we do? How do we establish any kind of trust in a world of flawless fakes? So what's the answer? Well, there's no single magic bullet. The key thing to realize is that in this constant cat and mouse game, you can't rely on just one tool. You need a strategy. And the current best practice is to use a sequence of randomized challenges. Think about it. An imposter might have trained their AI to handle turning its head. They might even have a model that can handle covering its face. But can it handle turning its head, then covering its face, then reacting to a sudden flash of light, all in a completely unpredictable order? That becomes exponentially harder to fake in real time. And that really leaves us with the central dilemma of this new era we're in. It's an arms race where both sides are using the exact same fundamental technology, AI to attack and to defend. So when one AI can create a perfect fake and another AI can perfectly hide that fake, the question of who wins isn't just a technical one anymore. It's a question about our own perception of reality itself.